Now that we know how to simplify radicals, we're going to look at the different operations we can do with radicals so that we can further simplify expressions involving radicals. The key to simplifying expressions with radicals is going to basically be a different form of combining like terms. Anywhere I see equivalent arguments or radicands, I'm going to be able to combine those. So if we look at our first example, both of those are square roots of 2, so I'm able to combine those just linking the coefficients. So we have -2 plus 3, we get 1. So we have 1 square root of 2. Remember, we don't always have to write the 1, so we just have the square root of 2. For the second example, I have roots of 2, but I also have roots of 6. Just like combining like terms, I can only combine terms that have exactly the same argument. So I have 2 root 2 minus root 2 gives me just 1 square root of 2 plus the 2 root 6. Since there's nothing there that matches, there's nothing to combine it with. Go ahead and try the last one on your own. Pause the video and see how you do. Hopefully you ended up with negative root 2 minus 8 root 3. We just combine again based on the common radicands. Now, sometimes our radicals aren't always going to be simplified. Before we can do any combining, we want to simplify the radicals to see if anything's going to match up. So if I look at the square root of 12, we know that that's going to be the square root of 4 times 3. So we end up with 2 root 3 there. Square root of 48 is going to be 16 times 3. So we're going to have 4 root 3 again. So now we've got 2 matching terms. And then the square root of 24, that's going to be square root of 4 times 6. So we have 2 root 6. Then we just bring down each of the signs that we already had, put them in the middle, and combine like we did before. So 2 root 3 plus 4 root 3 is going to be 6 root 3 plus the 2 root 6 that we have on the end. Pause the video, try the second one on your own. Alright, so first we go through and simplify negative root 75. That goes to 25 times 3, which gives us 5 root 3. Bring down the negative sign. We have negative 5 root 3. Then we have 5 root 90. So we have 9 and 10, which gives us 3 root 10, times the 5 outside, gives you 15 root 10. Bring down the negative sign, and repeat the process with the last term, and you end up combining them to get negative 5 root 3 minus 21 root 10. We can also multiply radical expressions together. So remember that when we simplified, we broke apart radicands using multiplication. Now we're going to put them back together using multiplication. Anything on the inside gets multiplied together, anything on the outside gets multiplied together. And here we're going to use our distributive property. So if we look at the first term, we have the square root of 2 times 4 root 6. That means everything on the inside gets multiplied together. Everything on the outside stays outside and gets multiplied. So here we're going to end up with 4 root 12. Then we go back to the other one, and we end up plus 2 root 2. But our answer is not completely simplified. So we have to break this radical down. We get 8 root 3 plus 2 root 2. Pause the video, try the other two on your own, see how you do with those. Alright, so if we look at the first one, we send that 2 root 6 through. We get negative 10 root 36. We know that square root of 36 is 6, so we multiply, we get negative 60. 2 root 6 times 3 gives you 6 root 6. For the second one, again, we focus on insides to insides, outside to outside. So negative 4 is on the outside. We multiply that by the 5p squared. We get negative 20p squared. The 3p stays on the inside. Then we have negative 4 times negative 4. Be careful with that. Negative gives us positive 16. Square root of 3p stays the same, but we have to reduce square root of 18p, so we pull out 9. That's going to give us 3 times the square root of 2p, and the 3 times the 16 gives you 48.